A single web request, no password, no login, no plugin. And on the two newest versions of WordPress, that was a full takeover of your server quietly for about a year. WordPress runs a third to 40% of every website on the planet, depending which analytics company is selling you a dashboard that day. Either way, that is a lot of sites to hand a bug like this. Normally we'd blame a plugin some guy abandoned back in 2015. Not this time. This time Core did it to itself. It is July 2026 and one deleted line of code is about to ruin a whole lot of Mondays. Two bugs, chain throw an endpoint ending in a web shell with 0 credentials. No login screen was harmed in the making of this exploit. Every WordPress horror story blames a plugin, a theme, some SEO tool last updated during the Obama administration. This one is Core doing exactly what Core always does, just slightly wrong. Quick scope check, because headlines love rounding a few sites up to the entire internet. This is 6.9 and 7.0. Default config, no plugins required. Still stuck on 6.8? Relax. Not your bug this time. You have other problems, but not this one. There is exactly one requirement, and the punchline is that almost everyone meets it. The site must have no persistent object cache, which is the default because WordPress doesn't ship one. So, unless you went out of your way to install Redis, your site qualifies. It was found by a researcher named Adam Hughes, disclosed July 17th, and patched the same day. 2 CVE numbers, 1 per bug because the paperwork insists. The bug is a full year old. A 6.9 refactor deleted a single line of validation and nobody retested the batch endpoint against garbage input. Why would they? Bug 1 lives in a filter called author __, not $_in. Its whole job is to accept a list of numbers. Is it an array? Sanitize, done. Not an array? It shrugs and builds the SQL query anyway. Send the string instead of an array and that string gets pasted straight into a database query. That's SQL injection. The bug the entire industry has been warning about since roughly the dawn of the web, and it still works. But WordPress will not even let you send that string. The REST schema demands an array of integers, no exceptions. So how does a type check field end up holding a raw string? Funny you should ask. Bug 2. The batch endpoint. It crams a pile of API calls into one post and validates them into 2 lists, side by side. Match routes over here, validation results over there. Send one deliberately broken URL and its error lands on the results list whenever on the matches list. From there, every request in the batch is reading one slot ahead, quietly wearing the identity of whoever is behind it in line. It's identity theft for HTTP requests. One snag. Batch sub-requests are only allowed to be post, put, patch, or delete, and the vulnerable field only answers to get. So the exploit buries a batch inside the batch, and suddenly get is invited in. Whoever wrote the schema validator did everything right. They just never pictured someone recursively stuffing a batch inside the batch inside the batch. We need to go deeper. Now every breathless write-up jumps straight to, and then it writes a PHP file to disk. That needs a MySQL privilege most hosts would never hand out. The real exploit doesn't bother, it found something classier. Using that injection, it writes forged records straight into the posts table, including a customizer change set stamped with a real admin's user ID. Then it fires a single request to run that change set, and WordPress executes it in that admin's security context. It never thought to ask whether the admin wanted any of this, which means it can now simply ask WordPress to create a brand new administrator account, politely, through the front door, with permission it was never given. No password, no hash to crack, no dramatic hacking montage, just vibes and a malformed URL. Then it logs in as the admin it just invented, uploads a plugin that happened to be a web shell, and runs whatever it likes. Let's recap. Account created, blog post forged, admin session hijacked, plugin uploaded. 4 separate systems wrecked by a URL with a typo in it. Ethics lower third. Everything you're about to see runs in my own lab, a throwaway WordPress container, not somebody's actual website. And I'm not going to just tell you it works. 1 command, 0 credentials. Watch the last line. UID 33 www data. This is the web server. owned pre-auth from a clean install. My favorite part, it never even guesses a password. It just asks WordPress to make it an admin, and WordPress goes, sure, seems legit. So how do you stop this? Well, WordPress already tried to fix it for you, whether you wanted it or not. The second this went public, WordPress shipped the patch to everyone. Well, everyone who left auto updates on, which you didn't because you are a real sysadmin who turns these off on principle and then forgets the site exists for 8 months. Before you patch, you can check without blowing up your own website. Send a batch request, and if a permission error comes back for a route you never called, congratulations, you are desynced. The actual fix is deeply boring. SSH in, check your version, update to 702 or 695, and that's it. This is the whole thing. And while you are in there, make sure your database user can write files to the server. It moves blog posts around. It does not need file system privileges, and grant all is not a security strategy. One deleted line opened this. 16 lines across 3 files closed it. That is the whole story. A rounding error that happened to give away the entire server. The lesson here isn't WordPress is insecure. It's the validation quietly dies the moment someone refactors a loop and nobody notices, because the bug is a off by 1 in an array, not a missing semicolon. If you write REST APIs of your own, validate at the boundary, then validate again after any code path that can hand you a different type than you asked for. 2 arrays that have to stay in lockstep are a trap. One branch updates one, skips the other, and they are silently desynced from then on. If data belongs together, store it together as one structure so it physically can drift apart. So go run the update, 702 or 695, one command, 5 minutes. Statistically, half of you won't, and that is exactly why this keeps happening. See you in the next one.